Welcome to another physics class. Today we are going to look at the topic motion under gravity. In one of our lessons, we discussed on linear motion, and under linear motion, we said F is equal to ma, where this our F is force, horizontal force, and this m is the mass of the object. A is linear acceleration. But today, when you say motion under gravity, we are going to use the same formula, but this our A will now change to G. And this our F now will now be force of attraction of the Earth on the body, where M will be the mass of the object, and G will be the acceleration due to gravity, or acceleration of free fall due to gravity. So when we now say motion under gravity, it simply means the motion of an object which is being influenced by acceleration due to gravity only. Again, motion under gravity means motion of an object which is being influenced or affected by acceleration due to gravity G. To write, we now say motion under gravity means the motion of an object which is influenced or affected by acceleration due to gravity. Acceleration due to gravity. That's the simple definition of motion under gravity. Now, the next thing we are going to look at the acceleration due to gravity itself, which the symbol is G. Acceleration due to gravity, or you call it acceleration of free fall. Acceleration of free fall due to gravity. When you say acceleration of free fall due to gravity, it means the force of attraction of the Earth on a unit mass, which is on the Earth's surface. I take it again. Acceleration due to gravity means the force of attraction of the Earth on a unit mass on the Earth's surface. That is, acceleration due to gravity, acceleration due to gravity. Don't forget the symbol is G. Is the force of attraction of the Earth on a unit mass on the surface of the Earth. That is, the force of attraction of the Earth on any object on the surface of the Earth is what meant by acceleration due to gravity. Or in another term, or it simply means acceleration due to gravity simply means that all objects all objects, no matter may be their masses. Their masses fall under gravity with the same acceleration. That is another way of defining acceleration of free fall due to gravity or acceleration due to gravity. Now, according to this definition, it means, or that is, F is equal to mg. As I said the other time, where this our F, where F is equal to, where F equal to force of attraction of the Earth on an object, and according to the definition, is the unit mass of an object on the Earth's surface, and G is the acceleration due to gravity. Acceleration due to gravity. Now, we can now say that, make G the subject now, we can now say that acceleration due to gravity, G, is equal to F over M. That is, in short, the magnitude of acceleration due to gravity under this topic depend on two factors, which are force of attraction of the Earth on a particular object on the Earth's surface, and two, mass of the object itself. Those are the two factors that determine the magnitude of acceleration due to gravity. To write, the magnitude of G depend on one, force of attraction of the Earth on an object, two, mass of the object on the Earth's surface. Now, the next thing is, let's look at facts or characteristics or properties of acceleration due to gravity G. Number one, this one, G is a downward acceleration. It's a downward acceleration. That is, when you throw any object up, definitely because of the acceleration due to gravity, the object must come down. So, acceleration due to gravity is a downward acceleration. Two, it varies from place to place. That is, when you take the value of acceleration due to gravity on a particular place, get to another place, the acceleration due to gravity will be different. That is why it is vary from place to place, depending on the geographical location of that particular place on the Earth's surface. 3, it has a constant constant value of 9.8 meter per second square. Once it is varied from place to place, then there must be a constant value. That is why in any calculation in physics, we take 9.8 meter per second square at the value of g as the constant value. Number 4, it is a vector quantity. Don't forget what we meant by vector quantity. That is quantity that has both magnitude and follow a specific direction. So, acceleration due to gravity g is a vector quantity. That is why we say it is a downward acceleration. That is specific direction that is followed on the earth surface. Number 5, its symbol is g. That is usually denoted by small g. Number 6 is a derived quantity. Is a derived quantity. It's a derived quantity. That is, from this formula, we can now say that acceleration due to gravity is a derived quantity. The derivation is F over m, that is force over mass. So it's a derived quantity. Number 7, all objects under the influence of acceleration due to gravity fall with the same speed. All objects under the influence of g fall with the same speed. What this one means is that when you take two objects, no matter maybe their masses, you drop them at the same time, especially inside a vacuum, they will fall with the same speed. You take a stone and a cotton wool in a vacuum, you drop them at the same height at the same time. Although stone is heavier than cotton wool, but the fact that due to acceleration due to gravity, they will fall with the same speed and light at the same time. That is why all objects under the influence of acceleration due to gravity fall with the same speed. Number 8, acceleration due to gravity g does not depend on the mass or masses of objects. As I said under number 7, that all objects fall under the influence of acceleration due to gravity fall with the same speed. That's so that the mass of such object does not affect the value of acceleration due to gravity. So once they will fall with the same speed, then no matter maybe the size or the magnitude of that object does not affect the acceleration due to gravity. Next is factors that affect or determine the magnitude or value of acceleration due to gravity on the Earth's surface. I think there are some factors that will determine the value of that G on the Earth surface. The number one factor is the rotation of the Earth. Rotation of the Earth along its axis. Now, this one affects the value of G on the Earth surface seriously, that is rotation of the Earth. As the Earth is rotating, causing day and night, it affects the value of G. So that is what makes its value varies from place to place depending on the geographical location of that particular object. So rotation of the Earth causes the variation. Number two factor is the shape of the Earth. The shape of the Earth. That is, Earth is not perfectly sphere, perfectly sphere in shape, but it is geode. The shape of the Earth, that is, Earth is not perfectly sphere. When you look at the shape of the Earth, it's something like this. Geode in nature, not perfectly sphere. So the fact that the Earth is not perfectly sphere, then it affects the value of G. Therefore, any position now that located at this place, the value of G compared with here will be different. As you move on the Earth surface, you have different value of acceleration due to gravity due to the shape of the Earth. So as I said, don't forget, the shape of the Earth affects the value of G. Look at, let's say this is the shape of the Earth, that is geode in nature, not perfectly sphere. A point is located here, another point is located here. They have different value of acceleration due to gravity, especially as you move from the equator to pole, or either north pole or south pole of the Earth. The value of G vary. Number three factor that determine the value of G on the Earth surface is the altitude of a place. What I mean by altitude? That is the height of a plate, the height of a particular place on the Earth surface determine the value of G. And since on the Earth surface all objects cannot have the same height, then it made the value of G vary. For instance, as drawn the other time, the constant value that we said G is equal to 9.8 meters per second square. This constant value is taken on the equator. That is the line that divides the Earth into north and south pole, is what we call the equator. So the constant value of G is taken on the equator, that is that 9.8 meters per second square. As you move, because of the height from equator to the north pole, the value of G gradually reduce. So when you get to the north pole, the value of G will reduce to the minimum value. Ditto to when you move from equator to the south pole. As you move from equator to the south pole, the value of G also reduce. Therefore, according to what we had the altitude, if you look at this one now, the distance from any part of the circumference of the Earth to the center of the equator is far, far greater than the distance of the same point from the equator to North Pole or South Pole. So due to that, these three factors, the value of G is always vary from place to place. And that is why we have them as factors that determine the magnitude of G on the Earth surface. As I said, that on the equator, the constant value of G is 9.8 meter per second square. What does that mean? This one means that the force of gravity on an object on this equator is increasing in value. Its velocity is increasing in value by 9.8 meter per second. I take it again because that question can be given. Explain the statement. The acceleration due to gravity on the equator is 9.8 meter per second square. And the statement can be explained like this, that it means the force of gravity on an object at the equator increases the velocity of an object by 9.8 meter per second, like that. Next is vertical motion. Vertical motion. Still under the same topic. Now, when you say vertical motion, is the motion of an object which is being influenced by 1. The acceleration due to gravity, 2. Weight of that object itself. I take it again. Vertical motion means the motion of an object which is being influenced by acceleration due to gravity and the weight of the object itself. Let's write. Vertical motion. Vertical motion means motion of an object that is influenced by acceleration due to gravity G and the weight of the object. That is, the vertical motion of an object that being influenced by the acceleration due to gravity G and the weight of an object. That's all that the two factors that will determine the vertical motion of an object is the value of acceleration due to gravity and the weight of that particular object. Take note of this. Vertical motion can be divided into two. Vertical motion is divided into two. 1. Object throwing up or moving up. Object throwing up or moving up. 2. Object falling down or moving down. moving down. Now, let's take it one after the other. Object throwing off vertically. Then what are the characteristics of this one? That is, when you throw an object up and it's moving up like this, going up according to the direction. Let's say this is the ground level. What are the possible characteristics? One, the initial velocity is 0. 2, when the object reaches the maximum height, the final velocity at maximum height reached by the object is 0. As I said, that is, when the object reaches the maximum height, here, the value of the velocity is equal to 0. According to number 1 statement, when the object starts from the ground level and move up, the initial velocity is equal to 0. Number 3 characteristic. 3. The velocity of the object is gradually decreases. That is, as it moves from the ground level up, the velocity will be gradually decreasing. That is why it is possible for that object to reach the maximum height. Let's say the velocity is increasing like that as it's moving up. It's not possible for it to reach the maximum, but the fact that as it moves up, gradually the velocity will be decreasing. Number 4, since the velocity is decreasing, and don't forget our topic is acceleration due to gravity, the value of g, that is the acceleration due to gravity, is negative. That is, it will take minus sign. So we have minus g when the object is moving up. Why is it minor? Because the value of g, the value of the velocity is decreasing. And again, the second reason, why is it minor? If you look at the direction of acceleration due to gravity, the direction of acceleration due to gravity is downward. But this one is moving up. Therefore, it is in opposite direction of acceleration due to, so the value of g here will be negative. Now, the next thing we are going to look at under object moving up is displacement time graph. That is, when you say displacement time graph and the object moves from the ground level, moving up, that is the height against time. So when you have height in meter, that is the height reached by the object against time. Time in second. Let's say this is the origin. So the displacement time graph, since the object is moving up, It will be like this. On reaching the maximum height, then definitely it will curve. So this is the maximum height now. Maximum height. That is how the displacement time graph will look like. Now the next thing is the velocity time graph. Velocity time graph. As we have displacement time graph, definitely we must have velocity time graph. So let's show the velocity time graph. Here is velocity in meter per second. Then origin 0, 0. Then this is time in seconds. Mind you, note this, we say at the object moving up, what will happen to velocity? Velocity will gradually decrease. If that is the case, so the velocity now will now decrease downward like that. So according to the statement, at maximum height, we said the velocity is what? 0. So it means this place will be the maximum, this is the point of maximum height now. Maximum height. That is this particular point where the velocity hits the ground. So this is the velocity is decreasing. Decreasing. This is the initial state now. So the velocity is decreasing until it reaches the maximum height. That is how the velocity time graph will look like. You may have it in mind that the velocity time graph will shoot up. No, according to the statement, that the velocity is gradually decreasing. So let's say this is the highest velocity now. Then it will gradually decreasing as it's moving up. So at that particular point where it hits the 0 mark again, then you have the maximum height. Now let's look at the second aspect, that is object falling downward from certain height. Object falling downward from certain height. Let's look at it again. Let's say this is the maximum height. Maximum height. And this object is falling downward. This is the ground level. So what are the characteristics now? Now, characteristic. As the case of objects moving up. 1. The initial velocity. The initial velocity. Initial velocity. Initial velocity. Velocity. U at maximum height as it falls down is equal to 0. That is the initial velocity as the body begins to fall down is equal to 0. 2. The velocity as it moving down increases. Just the opposite of object moving upward. The velocity as it's moving down increases. When the velocity is increases, number 3 characteristic, the value of G is positive. That is, it will take plus sign. Don't forget what determines the value of G, either it will be negative or positive, is the direction and the magnitude of the acceleration. Once the acceleration is decreasing, then you have negative acceleration due to gravity. But as in this case now, when the velocity is decreasing, you have positive acceleration due to gravity. So these are the three possible characteristics of object falling down from certain height. Mind you, as the object is moving down, like the case of object moving upward, its own velocity on hitting the ground cannot be 0. Let me add that one. Its velocity on hitting the ground cannot be 0. Those are the 4 characteristics also. Next is displacement time graph of object falling down from certain height. According to what we have on the board, that is, how the object is moving or falling down. The first thing is displacement time graph, and that will be height in meter again time in seconds. This is 0, that's the origin. That is, so as it's falling down, then you look at the height. The height also will increase like that. So the velocity time graph, displacement time graph will look like this. That is, the height will increase to some time as time increases, but it will curve as time goes on. The next one is velocity time graph. Velocity time graph. Velocity on the vertical axis, velocity in meter per second, and time in seconds, 0. Now, this is where you need to take note. We said as the object is moving down, what will happen to velocity? Velocity will increase, and this is 0. Therefore, the velocity time graph will increase like this. Velocity time graph will increase from 0 to any value until it hits the ground. So the velocity time graph will look like this. So you might think that the velocity time graph will be somehow different from this one. But according to the theory explained, the velocity time graph of an object falling down from certain height will increase from 0 to where it hit the ground. But note this one, the area bounded by this straight line graph, this area the area of the slope of the graph is equal to g, that is the acceleration due to gravity. Don't forget, because of objective question, the area bounded by this slope of the graph is equal to acceleration due to gravity, due to that of object moving up vertically, as we treated the other time. The next thing is equation of motion of an object under gravity. Note this one, this topic in physics. We have the theoretical aspect and the calculation aspect, at the same time as the practical aspect. So what we are still facing under this lesson is the theoretical and the calculation aspect. All the topic that we are going to look at, we are going to look at the theoretical aspect at the same time as the calculation aspect. When it is time for practical, we are going to look at the practical aspect also. That is why we named the channel as the Physics from Grassroots. As if you follow me right from the beginning and you continue progressively like that, at the end of the day, you must be a master in physics. So now, equation of motion of an object under gravity. According to the explanation that I have made, other object that is throwing up vertically, that is moving up like this vertically, an object that is coming down from certain height like this. This is how the curve, not the velocity time graph this time around, but the curve will look like. You throw it up, it will move up like this. Now, this point is the maximum height, this particular point, and when it reaches the maximum height, it will curve a little bit before it comes down like this. Now, the equation to represent this one, don't forget, I said the other time, all the characteristics we have written. Here we said, because this object is going up, we have minus g, and when it is coming down here, we have plus g. Why is it minus? The direction of g itself is downward. So an object moving up is that negative constant acceleration due to gravity. An object moving down is have positive downward acceleration due to gravity, because the direction of acceleration due to gravity, according to the one of the property, is downward acceleration. So from what I have said now, therefore we have two or three parts now. This part at maximum height, then at this part when it is coming down. Now, object moving up now. Object moving up. Object moving up. What are the possible equations when it is moving up? Don't forget, we said this is the part of moving up. This is maximum height, while this is part of moving down. Now, what we did now is we now go back to our linear equation of motion. As I said, when we are treating that topic, we said we have three major equations, which are V is equal to U plus or minus AT. Now for this equation 1 now, since we are dealing with acceleration due to gravity now, our equation for this side will now be 1. V is equal to U plus minus GT. You notice something. Our A here is changed to G, because Here is linear acceleration. Here we are talking about acceleration due to gravity. So all the equations that we are going to write here are from linear equation of motion. But the only difference is that where we have our A for linear acceleration, we are going to change it to G. Now, the equation 2 under linear motion is S is equal to ut plus or minus half at square. For this side, which is negative now, since this one is horizontal distance, here now we are not talking about horizontal distance. What we are talking about is height. So our S we change to h, then equal to u, since it is this side, minus half gt squared. Then the third equation, which is v squared is equal to u squared plus or minus 2as. A we change to g, s we change to height. So we are going to have v squared is equal to u squared on this side minus 2gh. That is on this side. Now, for the other side also, which when it is coming down, so we are going to have object falling down. What are the possible equations? Without wasting our time, you can now say that 2, 3. You can now say that the equation 1 of this one will be v is equal to u plus gt. Why it says plus? Because it is coming down. There's an increase in velocity. When there is an increase in velocity, then you have positive value for g. Then equation 2 will now be 8 is equal to ut plus half gt squared. Our explanation remains the same. Equation 3 will now become v squared is equal to u squared plus half, plus 2a and 2gh. A saying to g, s saying to I. As I said the other time, this is horizontal distance, while this one is vertical height. Now combine the two side equations together. We are going to have the general formula as general equation as V1. V is equal to U plus or minus GT. 2. H is equal to UT plus or minus half GT squared. And 3. V squared is equal to U squared plus or minus 2GH. That is the general equation for an object moving under gravity. Now, to define or to identify its sign there, or symbol here, where V is equal to final velocity, U is equal to initial velocity, there G is acceleration due to gravity. Mind you, not gravity. It is called acceleration due to gravity. And here is vertical height. Vertical height. Those are the possible notation that is there. Then we still have t. T is equal to time taken. Those are the possible notation there. Then don't forget, as I said, at maximum height. Note this one down. At maximum height, final velocity, final velocity is 0. That's at maximum height, final velocity is 0 when object is moving up. When you throw it up, the final velocity at maximum height is equal to 0. Now, let's look at velocity time graph of an object under gravity. This one is just the combination of what we've done the other time. Don't forget, we've done vertical motion. When an object is moving up, we've drawn the velocity time graph. At the same time, when an object is falling down, we draw the velocity time graph. Let's now combine now. When that object is under gravity and is throwing off vertically, reaching the maximum height and come back to the ground, how does the velocity time graph will look like? An object thrown vertically upward reaches the maximum height and fall down to the ground. So velocity time graph now. The velocity time graph of such subject now. Let's look at it. This velocity in meter per seconds, time in second. This is origin 0, 0. Now, we just want to combine the motion together now. When it is thrown up, we agree the other time that the velocity will decrease. So the velocity will decrease like this. There will be decrease in velocity. On reaching maximum height, the velocity will be equal to 0. So this is this point now, the maximum height. Let's call it h. Now, on reaching maximum height, we explained that on coming down, the velocity will increase. So it will increase like this. So now there will be decrease in velocity, decrease in velocity when it is coming down. Then when it is going up, when it is coming down now, there will be increase in velocity. Now, point H is equal to maximum height. So this is how the velocity time graph will look like for an object throwing up vertically from the ground and reaches the maximum height and fall back to the ground. So as it's throwing up, the velocity will decrease. It reaches the maximum height, the velocity will increase. So this is how the velocity time graph will look like. It is on this note we are going to stop for today. In our next video, we are going to look at calculation under this topic. As I said, physics is divided into three parts: the theoretical part, the calculation part, and the practical part. So now, the theoretical part of this one, we will see it. In our next video, we are going to look at the calculation aspect, in which we are going to use all this formula to solve series of questions. And as I always say, if you are new to this channel, please don't forget to share, like, and subscribe. So when I upload a new video, you'll be able to get the notification in time. Thank you.